Australia and New Zealand are home to some of the world's most demanding structural engineering challenges. Every bridge, building, and industrial structure must safely resist the forces of nature. Engineers design these structures to withstand gravity, wind, earthquakes, and many other extreme conditions. Each project begins with one essential question: how will the structure carry every load safely? The answer lies in understanding how forces travel through an entire structural system. Every structural element has a specific purpose in transferring those forces safely to the ground. From the roof to the foundation, every connection plays an important role. A safe structure is not created by chance. It is created through engineering. Structural engineering combines science, mathematics, and practical experience into one complete design process. Every calculation helps engineers predict how a structure will behave before it is ever built. Australia presents unique challenges, including cyclones, bushfires, flooding, and corrosive coastal environments. New Zealand adds another major challenge, with powerful earthquakes and active seismic zones. Despite these different conditions, both countries share the same goal: designing structures that remain safe and reliable. Throughout this documentary, we will explore the engineering principles that make this possible. Let's begin by understanding what a structural engineer really does. A structural engineer is responsible for making buildings and structures safe. Every structure must safely carry all the loads acting upon it.
The load path always begins where the loads are first applied.
From there, the loads travel safely through beams, columns, and into the foundation. Finally, the foundation transfers every load safely into the supporting soil. Engineers then analyze how the entire structure responds to these applied loads. This analysis predicts whether the structure will remain safe under real conditions. Using these results, engineers design every structural member to meet safety requirements. Every beam, column, and connection is carefully checked before construction begins.
Finally, engineers help ensure the structure is built exactly as it was designed.
Australia offers one of the world's most diverse structural engineering environments.
Engineers design everything from residential homes to massive industrial and mining structures.
Every structure must be designed to perform safely under Australia's demanding environmental conditions. Strong winds and tropical cyclones create enormous forces that every structure must resist. Coastal structures require special protection against corrosion caused by salt and moisture. Despite their differences, every structure follows the same fundamental engineering principles. New Zealand presents a completely different set of structural engineering challenges.
Much of New Zealand lies along active tectonic plate boundaries, where earthquakes occur frequently. Engineers design buildings to move safely during earthquakes, rather than trying to stop all movement. Ductility allows a structure to bend and absorb energy without suddenly failing. Modern seismic systems dissipate earthquake energy before it can seriously damage the structure.
Base isolation reduces the amount of earthquake motion transferred into the building.
Effective seismic design protects lives by allowing structures to respond safely during earthquakes.
Every structural design begins by following recognized engineering standards and design codes. Engineering codes guide every step, from load calculations to the final structural design. Design codes first define every load that the structure must safely resist.
Engineers analyze the structure to predict how it will respond under every design load. Only after every code requirement is satisfied can the structure be approved for construction. AS/NZS 1170 defines the structural loads that every building must safely resist.
AS 3600 provides the design requirements for reinforced concrete structures. AS 4100 establishes the design rules for structural steel members and connections. AS 1720.1 specifies how structural timber members are safely designed. Although the standards differ, both countries share the same objective of safe structural design.
Wind engineering begins by understanding how moving air applies forces to a structure.
Wind creates both pushing pressure and lifting suction as it flows around a building. Roof uplift is one of the most critical effects that engineers must consider during wind design. Wind forces must travel through a continuous load path until they safely reach the foundation. A properly engineered structure safely transfers wind forces without compromising stability. Taller buildings experience greater wind effects and require more detailed structural analysis. Terrain and surrounding buildings significantly influence the wind loads acting on a structure. In cyclone regions, structures require additional strength to resist extreme wind forces. Safe wind design combines accurate load calculations, structural analysis, and code compliance. Every engineering decision contributes to creating safer and more resilient structures for the future. The future of structural engineering is being transformed by intelligent digital technologies. Modern engineers can evaluate more design possibilities than ever before using advanced computational tools. The next generation of structures must be both environmentally responsible and structurally resilient. Every successful structure begins with a clear understanding of how forces move through the entire system. Structural engineering transforms scientific principles into safer, stronger, and more resilient communities. Every successful structure is designed with safety, performance, and long-term durability in mind. Great engineering prepares structures to withstand the challenges of both nature and time.
Every great structure begins with understanding forces and ends with protecting the people who depend on it. Thank you for watching. Keep learning, keep engineering, and we'll see you in the next documentary.